In 1977, a radio telescope in Ohio detected something that shouldn't exist, a signal so powerful and precise that astronomers have spent 50 years trying to explain it away. They called it the wow signal, and for decades, we thought we understood what made it special. We were wrong. Recent analysis of recovered data reveals this cosmic mystery was far more bizarre than anyone imagined, twice as powerful, moving at incredible speeds, and potentially rewriting the rules of what's possible in our galaxy. If you enjoy diving into cosmic mysteries, hit that like button. Prepare yourselves. We begin. Picture this. You're scanning the cosmos for signs of intelligent life, and suddenly your equipment detects something impossible. A radio signal so intense, so perfectly structured, that it could only come from advanced technology. This wasn't random cosmic noise or a glitch in your instruments. This was a message. On August 15th, 1977, that exact scenario played out at Ohio State University's Big Ear Radio Telescope. The massive dish, part of humanity's first serious attempt to find extraterrestrial intelligence, captured something that defied explanation. For 72 seconds, a signal blazed across the cosmos with the kind of precision that made scientists' hearts race. But here's what made this discovery earth-shattering. The signal appeared at exactly 1420 megahertz, a frequency astronomers call the hydrogen line. Think of it as the universe's natural radio station, the frequency hydrogen atoms use to communicate across space. Any advanced civilization would know this frequency, making it the perfect choice for an interstellar greeting card. The intensity was staggering. While most cosmic radio sources whisper across the void, this signal screamed. It was so powerful that it immediately stood out from the background noise of our galaxy. Imagine trying to hear a conversation in a crowded stadium, then suddenly someone starts shouting through a megaphone. That's how obvious this signal was. What really stunned astronomers was the signal's behavior. As Earth's rotation carried the telescope across the sky, the signal's strength rose and fell in a perfect bell curve. This pattern proved the source was stationary in space, sitting somewhere far beyond our solar system. No satellite, no aircraft, no earthly technology could create this signature. The discovery sent shockwaves through the scientific community. After decades of listening to cosmic silence, we finally had what appeared to be evidence of intelligent life. The implications were staggering. If this was real, it meant we weren't alone. It meant somewhere in the vast darkness, another civilization was trying to reach out. But the signal vanished as mysteriously as it appeared. Follow-up observations found nothing. The cosmic silence returned, leaving scientists with more questions than answers. Was this a one-time message? A malfunction in distant alien technology? Or something else entirely? For nearly 50 years, the WOW signal remained our best and only candidate for extraterrestrial communication. It became the holy grail of alien hunters, the one piece of evidence that suggested we might not be alone in the universe. Scientists analyzed every aspect of the signal, searching for clues about its origin and meaning. Yet despite decades of investigation, the truth remained elusive. The signal had appeared for just over a minute, then disappeared forever, leaving behind only a computer printout and a legacy of mystery that would captivate generations of researchers. But recent discoveries have shattered everything we thought we knew about this cosmic enigma. 3 days after the signal blazed across space, astronomer Jerry Ehman sat down at his desk with a stack of computer printouts. This was routine work, the kind of tedious data review that defined the search for extraterrestrial intelligence. Day after day, month after month, researchers combed through endless streams of numbers, hoping to find something extraordinary, hidden in the cosmic static. Ehman was reviewing data from August 15th when something made him stop cold. There, printed in faded ink on cheap computer paper, was a sequence that shouldn't exist. The numbers climbed impossibly high, representing radio intensity far beyond anything they'd seen before. 6 characters stood out like a beacon: 6EQUJ, 5. But here's what most people get wrong about the WOW signal. Those letters and numbers weren't a message from aliens. They were simply the computer's way of representing signal strength. The Big Ear telescope used a clever coding system where numbers 1 through 9 represented weak signals and letters A through Z represented increasingly powerful ones. When the signal strength exceeded even the letter Z, the computer moved to other characters. That sequence told a story of escalating power. The signal had started weak, climbed to incredible intensity, then faded away. But the peak strength, represented by that single letter U, was off the charts. This wasn't just strong for a cosmic signal. This was strong compared to anything they'd ever recorded. Eamon stared at the printout, his mind racing. In all his years of searching, he'd never seen anything like this. The pattern was too perfect, too structured to be random noise. This looked exactly like what they'd been hoping to find: evidence of intelligent design from somewhere beyond Earth. Unable to contain his excitement, Eamon grabbed a red pen and circled the anomalous sequence. In the margin, he scrawled a single word that would become legendary in the annals of astronomy: wow. It was a spontaneous reaction to something that seemed impossible, a moment when scientific skepticism gave way to pure wonder. That handwritten exclamation became the signal's unofficial name. The WOW signal wasn't chosen by committee or scientific convention. It was simply the gut reaction of a researcher who'd just witnessed something extraordinary. In a field where discoveries are usually announced with careful language and peer review, this was refreshingly human. Eamon immediately shared his find with colleagues. The excitement was infectious as word spread through the astronomy community. After years of listening to cosmic silence, they finally had something that looked like a genuine signal from an intelligent source. The implications sent ripples through scientific circles and captured public imagination worldwide. But even as excitement built, questions multiplied. Where had this signal originated? Why had it appeared just once? And most importantly, would they ever hear from this cosmic source again? The search for answers was about to begin, launching a mystery that would consume researchers for decades. The timing was too perfect to ignore. 72 seconds. Not 70, not 75, but exactly 72 seconds of cosmic transmission. This precise duration immediately raised red flags among researchers because it matched something very specific about how radio telescopes work. Here's what made that timing so suspicious. The Big Ear telescope wasn't like a camera that could point anywhere in the sky. Instead, it sat fixed while Earth's rotation carried it across the heavens, like a giant celestial scanner. As our planet spun, the telescope's view swept across space at a predictable rate, spending exactly 72 seconds looking at any given point. This meant the WOW signal lasted for precisely the amount of time the telescope could observe its source location. Imagine a lighthouse beam sweeping across the ocean. A ship would see the light grow brighter as the beam approached, reach peak intensity when pointed directly at them, then fade as it moved away. That's exactly what happened with the WOW signal. The signal's intensity curve was textbook perfect. It started weak, climbed steadily to maximum strength, then faded away in a symmetrical pattern called a Gaussian distribution. This bell-shaped curve was exactly what astronomers expected from a distant, stationary radio source. The mathematics were beautiful, the pattern unmistakable. But this perfection created a puzzle. If the signal was artificial, why would aliens time their transmission to match our telescope's observation window? They couldn't possibly know when Earth's rotation would point our antenna in their direction. The timing seemed like an impossible coincidence. Some researchers wondered if the duration proved the signal was natural rather than artificial. Maybe they were looking at a cosmic phenomenon that lasted exactly as long as they could observe it. But what natural process could produce such a powerful, narrowband radio signal with perfect timing? The signal's behavior also ruled out many Earth-based explanations. Aircraft moved too quickly to create a 72-second signal. Satellites follow predictable orbits that would create different timing patterns. Even secret military technology couldn't explain the precise duration and intensity curve. Weather balloons and atmospheric phenomena were also eliminated. These sources would create signals that varied randomly with wind patterns and atmospheric conditions. The WOW signal showed none of this chaos. Instead, it displayed the kind of mathematical precision that suggested a stable, distant source. The duration also meant the signal was incredibly powerful. For something to be detected across interstellar distances while lasting only 72 seconds, it needed tremendous energy output. We're talking about power levels comparable to entire stars focused into a narrow radio beam. This led to wild speculation about alien megastructures and cosmic engineering projects. What kind of civilization could harness such enormous energies? Were we witnessing the operation of technology beyond our comprehension? The 72-second duration became one of the signal's most analyzed features. Researchers used it to calculate distance estimates, power requirements, and possible explanations. Every theory had to account for this precise timing, but the perfect duration would soon reveal secrets that nobody expected. 1420 MHz. In the vast spectrum of cosmic radio noise, this frequency stands out like a neon sign in the darkness. It's not random, it's not arbitrary. It's the universe's most fundamental radio frequency, and any intelligent civilization would know its significance. This wavelength belongs to hydrogen, the most abundant element in the cosmos. When hydrogen atoms flip their electron spin, they release energy at exactly this frequency. It's like a cosmic heartbeat, pulsing throughout every galaxy, every nebula, every corner of space where hydrogen exists. And since hydrogen makes up roughly 75% of all normal matter in the universe, this frequency is everywhere. But here's why this wavelength was so significant for alien hunters. Back in 1959, physicists Giuseppe Cocconi and Philip Morrison published a groundbreaking paper that changed how we think about interstellar communication. They argued that any advanced civilization trying to contact other worlds would choose the hydrogen line frequency. Think about it from an alien perspective. You want to send a message across the galaxy, but space is filled with radio noise from countless natural sources. Stars, pulsars, and cosmic phenomena create a constant background chatter that could drown out your signal. You need a frequency that stands out, something unmistakably artificial against the natural backdrop. The hydrogen line was perfect for this purpose. While hydrogen atoms naturally emit at this frequency, they do it in a very specific way. Natural hydrogen emission is usually spread out, diffuse, and relatively weak. An artificial signal at this exact frequency would be like writing your name in bright letters across a cloudy sky. This reasoning became the foundation of the Search for Extraterrestrial Intelligence program. Astronomers worldwide began monitoring 1420 MHz, listening for patterns that couldn't be explained by natural processes. They called this frequency the water hole, since hydrogen, combined with oxygen, makes water, the essential ingredient for life as we know it. The frequency also made practical sense for space communication. Radio waves at 1420 MHz travel efficiently through space without being absorbed by dust clouds or disrupted by stellar interference. It's like finding the perfect channel on a cosmic radio dial. When the WOW signal appeared at exactly this frequency, it sent shockwaves through the scientific community. This wasn't just any random radio burst. This was a signal appearing at the one frequency that theorists had predicted aliens would use for interstellar communication. The coincidence seemed too perfect to ignore. The signal was also incredibly narrow-band, focused precisely at 1420 MHz without spreading to nearby frequencies. Natural cosmic sources usually broadcast across wide ranges of frequencies. This laser-like precision suggested artificial origin, the kind of focused transmission that required advanced technology. Astronomers had been monitoring this frequency for years without finding anything unusual. Then, suddenly, this powerful signal blazed across the cosmos at exactly the wavelength they'd been watching. It was like fishing in a specific spot for years, then having the biggest fish in the ocean jump directly into your boat. The implications were staggering, and researchers knew they were looking at something unprecedented. The unthinkable happened in 1998. After decades of cosmic listening, the Big Ear radio telescope fell silent forever. Budget cuts forced Ohio State University to shut down the facility, and with it went what researchers thought was their only window into the WOW signal's secrets. But the real tragedy wasn't just losing the telescope. In the chaos of closing down the observatory, something far more precious vanished: the original data. Mountains of computer printouts, magnetic tapes, and observational records that contained decades of cosmic surveillance simply disappeared into storage facilities, or, worse, into dumpsters. This wasn't just any data. These records contained the raw observations from one of humanity's most ambitious scientific projects. Every night for over 20 years, the Big Ear telescope had scanned the skies, recording radio signals from distant galaxies, pulsars, and cosmic phenomena. Hidden, somewhere in those endless streams of numbers, were potentially world-changing discoveries. The WOW signal printout survived because Jerry Eman had kept his personal copy, but everything else seemed lost. Researchers faced a heartbreaking reality. They had found the most promising evidence of extraterrestrial intelligence in human history, but the context surrounding that discovery was gone forever. Without the complete dataset, scientists couldn't properly analyze the signal's environment. They couldn't study what happened before or after the famous 72 seconds. They couldn't compare the signal to other observations from the same region of sky. The WOW signal existed in isolation, a single moment torn from its cosmic context. This data loss became one of astronomy's greatest tragedies. Imagine discovering a single page from Shakespeare's lost plays, then realizing you've thrown away the entire library. That's how researchers felt as they watched decades of observations vanish into oblivion. The scientific community was devastated. Young astronomers who had dedicated their careers to studying the signal found themselves working with fragments. Theories proliferated, but without additional data, there was no way to test them. The WOW signal became frozen in time, a mystery that seemed destined to remain unsolved. Insurance companies wouldn't cover the storage costs for old scientific data. Universities saw computer printouts as worthless paper, taking up valuable space. What seemed like routine administrative decisions turned into irreversible scientific losses. The data that could have unlocked cosmic secrets was treated like yesterday's newspaper. Some researchers tried desperately to locate missing records. They searched through university basements, contacted former employees, and even dug through storage facilities. Most searches ended in disappointment. The data had been destroyed, recycled, or lost to time and neglect. The loss seemed complete and permanent. For nearly 2 decades, scientists resigned themselves to working with limited information. The WOW signal would remain an eternal mystery, its secrets locked away forever. But sometimes heroes emerge from the most unexpected places, and the story of the missing data was about to take a remarkable turn. Enter Robert Gray, an amateur astronomer with an obsession and a camera. While professional researchers mourned the loss of Big Ear's data, Gray was quietly embarking on one of the most ambitious data recovery projects in scientific history. He had discovered something extraordinary. The data wasn't completely gone. In the basement storage areas of Ohio State University, forgotten and gathering dust, sat box after box of original computer printouts from the Big Ear project. These weren't copies or summaries. These were the actual records from every night of observation, the raw data stream that had captured the WOW signal and thousands of other cosmic events. Gray realized he was looking at a treasure trove of astronomical data that the scientific community thought was lost forever. But there was a problem. The printouts were deteriorating. The cheap paper was yellowing, the ink was fading, and time was running out. If someone didn't act quickly, these irreplaceable records would crumble into dust. So Gray did something that seemed impossible. Between 2006 and 2017, he systematically photographed over 75,000 individual printout pages. Picture someone documenting every page of a massive library before it burns down. That's the scale of what Gray accomplished, working alone with nothing but determination and basic photography equipment. This wasn't just pointing a camera and clicking. Each page had to be carefully positioned, properly lit, and photographed at high resolution to capture the faded numbers and letters. The data was printed in continuous streams across wide computer paper, with tiny characters that required precise focus. A single blurry photo could mean losing crucial information forever. Gray worked methodically, page by page, box by box. He photographed observation logs from 1977 through 1984, capturing not just the wow signal period, but years of surrounding data. This created a complete picture of what the Big Ear telescope observed during its most active period. The project consumed over a decade of Gray's life. He spent countless hours in dusty basements, hunched over printouts with his camera, knowing that each page might contain undiscovered cosmic secrets. He funded the entire project himself, driven by the belief that this data was too valuable to lose. When Gray finished, he had created something unprecedented, a complete digital archive of 1.24 terabytes of astronomical data. This massive collection contained millions of individual observations, each one a snapshot of cosmic radioactivity from decades past. But having the photographs was only the beginning. The real challenge was turning faded printouts into usable scientific data. The numbers and letters were often barely visible, distorted by age and poor printing quality. Converting this visual information back into numerical data would require technology that didn't exist when the observations were first made. Gray's heroic effort had saved the data from destruction, but unlocking its secrets would require a completely different kind of innovation. The photographed printouts were just the first step. 75,000 pages of faded numbers and letters needed to be converted back into the digital format that modern computers could analyze. This was like trying to read a library of books written in disappearing ink, then typing every word back into a computer. Traditional optical character recognition software failed completely. The printouts were too old, too faded, and printed in fonts that modern software couldn't interpret. The dots and dashes that represented radio intensity measurements looked like random marks to standard OCR programs. Something more sophisticated was needed. Enter a team of researchers led by Antonio Paris, who developed specialized software designed specifically for reading astronomical data from vintage computer printouts. This wasn't ordinary text recognition. They were teaching computers to understand the unique formatting, numbering systems, and layout patterns used by 1970s radio telescopes. The software had to learn how Big Ear's computers recorded data. Each column represented a specific frequency range. Each row showed measurements taken at precise time intervals. The intensity values were coded using a mix of numbers and letters that created patterns across the page. Modern computers had to be taught this decades-old language. But the real breakthrough came when the software began revealing data that human eyes had missed. Hidden in the faded printouts were observations that researchers had never properly analyzed. The OCR system could detect faint markings that were invisible to casual inspection, uncovering radio events that had been overlooked for decades. As the software processed more pages, patterns began emerging from the noise. The wow signal wasn't alone. Scattered throughout the data were other unusual radio events, some showing similar characteristics to the famous signal. These discoveries suggested that powerful cosmic radio bursts might be more common than anyone realized. The OCR analysis also revealed something crucial about the wow signal itself: the surrounding context. For the first time since 1977, researchers could see what happened before and after those famous 72 seconds. They could analyze the background radio environment and compare the signal to other observations from the same night. This contextual data immediately ruled out several theories about the signal's origin. There were no other unusual radio events in the surrounding time period. No gradual buildup, no aftermath, no related phenomena. The signal appeared suddenly, burned brightly for exactly 72 seconds, then vanished completely. The software also revealed measurement details that had been lost in previous analyses. The original intensity calculations had been simplified over the years as the data passed through multiple researchers. Now they could see the actual numbers recorded by the telescope, not the rounded estimates that had appeared in scientific papers. These precise measurements would prove crucial for understanding what really happened on that August night in 1977. The newly recovered data contained clues that would reshape everything scientists thought they knew about the WOW signal. But the biggest surprises were yet to come. The location had always been uncertain. For over 40 years, astronomers knew roughly where the WOW signal came from, but they couldn't pin down the exact coordinates. This wasn't just an academic problem. Without precise location data, follow-up observations were shooting in the dark, literally searching the wrong parts of the sky. The uncertainty came from how the Big Ear telescope worked. Unlike modern radio dishes that can point anywhere, Big Ear used two fixed antenna horns that observed the same region of sky with a 3-minute delay between them. As Earth rotated, these horns swept across space like twin searchlights, each recording what they detected. Here's where things got confusing. The WOW signal appeared in only one of the two horns. This created a fundamental ambiguity about its origin. Did the signal come from the first horn's observation zone, or the second? The difference placed the source in completely different parts of the constellation Sagittarius. Previous researchers had essentially guessed at the location, picking one horn's data over the other without definitive proof. This uncertainty meant that every follow-up search over the past 4 decades might have been looking in the wrong place. Imagine trying to find a lost city when your map could be wrong by hundreds of miles. The newly recovered data changed everything. By analyzing the complete observation sequence and cross-referencing timing patterns, researchers finally determined which horn detected the signal. The mathematics were conclusive, eliminating decades of location ambiguity. But here's the shocking part. The true location was significantly different from what most people had assumed. The signal originated from coordinates that were 7.2 4 arc-minutes away from the commonly cited position. In cosmic terms, that's a substantial displacement, like discovering that a landmark you've been navigating by is actually in the next county. This revelation had immediate implications for future searches. Astronomers who had been monitoring the traditional WOW signal coordinates were looking at empty space. The actual source location had been largely ignored for decades, simply because researchers were using the wrong star charts. The precise coordinates also allowed for much more detailed analysis of the signal's environment. Astronomers could now examine exactly what stellar objects, gas clouds, and cosmic phenomena existed in that specific region of space. They could search astronomical databases for anything unusual at those exact coordinates. This location refinement eliminated several theories about the signal's origin. Some researchers had suggested the signal came from specific stars or known radio sources in the general area. The new coordinates moved the source away from these objects, ruling out explanations that had seemed plausible for years. The corrected location also provided new search targets for radio telescopes. Instead of randomly scanning the broader Sagittarius region, astronomers could now focus their instruments on the exact spot where the signal originated. This precision dramatically improved the chances of detecting follow-up signals or related phenomena. But the location correction was just the beginning. The recovered data held even bigger surprises about the signal's fundamental properties. The coordinate correction wasn't just about pointing telescopes in the right direction. It fundamentally changed how astronomers understood the signal's cosmic environment and what might have produced such a powerful radio burst. The corrected location placed the WOW signal in a region of space that was far more interesting than previously thought. Instead of originating from the relatively empty areas that earlier estimates suggested, the true coordinates pointed toward a zone rich with cosmic activity. This was a region where multiple stellar systems, gas clouds, and high-energy phenomena overlapped. Astronomical databases revealed something fascinating about this location. The corrected coordinates placed the signal near several known radio sources, though not close enough to be directly associated with them. This created a new puzzle. Why would such a powerful signal appear in a cosmically active region without being connected to any specific known object? The location also changed distance estimates for the signal source. Previous calculations had assumed the signal came from one general area, leading to specific conclusions about how far away and how powerful the source must be. The coordinate correction required completely new calculations, potentially placing the source at different distances with different energy requirements. This had huge implications for theories about what created the signal. If the source was closer than previously thought, it wouldn't need to be as powerful to produce the observed intensity. If it was farther away, the energy requirements became even more staggering. The new location demanded fresh analysis of every aspect of the signal's origin. The corrected coordinates also aligned better with certain astronomical phenomena that researchers were beginning to suspect might be connected to the signal. Cold hydrogen clouds, for instance, were known to exist in that region of space. These clouds could potentially produce powerful radio emissions under specific conditions, but only if illuminated by nearby high-energy sources. Radio telescope surveys of the new location revealed subtle but intriguing details. While no obvious radio sources appeared at the exact coordinates, sensitive instruments detected faint background emissions that varied over time. This variability suggested active processes in the region, even if nothing as dramatic as the original WOW signal had been observed since. The location correction also impacted how researchers interpreted the signal's duration and intensity curve. The new coordinates placed the source in a region where Earth's rotation would carry the telescope across the signal location at a slightly different rate than previously calculated. This refined the timing analysis and provided more accurate estimates of the signal's true behavior. Most importantly, the precise coordinates gave astronomers a much better foundation for ongoing searches. Instead of broadly scanning the Sagittarius region and hoping to rediscover something unusual, they could now focus on a specific location where they knew something extraordinary had definitely occurred. The coordinate refinement represented more than just improved accuracy. It opened entirely new avenues for understanding what might have created the most famous, unexplained signal in astronomical history. Everything astronomers thought they knew about the WOW signal's power was wrong. For decades, researchers estimated the signal's strength at somewhere between 54 and 200 Janskis, already making it an exceptionally powerful cosmic radio source. The new analysis revealed a shocking truth. The signal was at least 250 Janskis, making it significantly more intense than anyone had calculated. This wasn't just a small correction in scientific measurements. This was a fundamental revision that changed everything about how researchers understood the signal's origin. Doubling the power meant doubling the mystery. Whatever created this signal was far more energetic than any previous theory could explain. To understand why this matters, you need to grasp how radio intensity works in astronomy. A Jansky measures how much radio energy reaches Earth from a cosmic source. It's an incredibly tiny unit, representing about 10 to the negative 26 watts per square meter per hertz. These are measurements so small that detecting anything requires extremely sensitive equipment. The intensity revision came from better calibration of the original telescope data. The Big Ear telescope's sensitivity had been estimated using the technology and methods available in 1977. Modern analysis techniques, combined with more sophisticated understanding of radio telescope behavior, revealed that the original estimates were conservative. The recalibrated measurements showed the signal blazing across space, with power levels that put it in an elite category of cosmic radio sources. Only the most energetic phenomena in the universe operate at these intensities. Supermassive black holes, the most powerful stellar explosions, and exotic objects like magnetars. But here's what made the intensity revision so puzzling. The signal appeared at exactly 1420 MHz, the hydrogen line frequency, with laser-like precision. Natural cosmic sources that produce this much power typically broadcast across wide ranges of frequencies. They're like cosmic boomboxes, loud but unfocused. The WOW signal was more like a cosmic laser pointer, incredibly powerful but precisely targeted. This combination of extreme power and narrow frequency focus eliminated many natural explanations. Stellar explosions, galactic collisions, and other high-energy cosmic events simply don't work this way. They create broad-spectrum chaos, not focused precision. The intensity revision made the signal even more mysterious, not less. The power calculations also revealed something disturbing about the signal's source. To produce 250 Janskis at interstellar distances required energy output comparable to entire star systems. We're talking about power levels that dwarf anything humanity has ever created, focused into a radio beam narrow enough to fit through a keyhole. This led to wild speculation about cosmic engineering projects. What kind of civilization could harness such enormous energies? Were we witnessing technology that operated on galactic scales, using entire stars as power sources for interstellar communication? The intensity revision also made the signal's brief duration even more puzzling. Whatever created this enormous burst of energy did so for exactly 72 seconds, then shut off completely. The precision was as remarkable as the power itself. 250 Janskis sounds like scientific jargon, but translate it into real-world terms, and the numbers become staggering. This intensity level puts the WOW signal among the most powerful radio sources ever detected, competing with phenomena that normally require the death of massive stars or the feeding of supermassive black holes. Let's start with familiar comparisons to understand this cosmic power scale. Our Sun, when it's relatively quiet and not producing solar flares, emits about 1,000 Janskis at 20 MHz. So the WOW signal was roughly 1/4 as powerful as our entire star, but focused into a much narrower frequency band. Imagine squeezing a quarter of the sun's radio output through a cosmic funnel. Step up to galaxy-scale emissions, and the perspective shifts dramatically. The entire Milky Way galaxy, with its 400 billion stars, gas clouds, and cosmic phenomena, produces roughly 1 million Janskis of radio emission. The WOW signal represented about 1/4000th of our galaxy's total radio output, concentrated in a single precise frequency from a single point source. But here's where the comparison gets truly bizarre. A smartphone operating just 1 kilometer away from a radio telescope can produce up to 110 million Janskis if its signal is intercepted directly. This means the WOW signal, coming from interstellar space, was incredibly weak by technological standards, but impossibly strong for a natural cosmic source. The intensity calculation reveals the staggering energy requirements at the source for a signal to travel across interstellar distances and still register at 250 Janskis. The original transmission must have been phenomenally powerful. We're talking about energy outputs that require exotic physics or technology far beyond human capabilities. Consider the most powerful radio sources known to astronomy. Quasars, which are supermassive black holes actively consuming matter, can produce radio emissions this strong. But quasars broadcast across enormous ranges of frequencies, creating the cosmic equivalent of white noise. The WOW signal was precisely tuned, like finding a single perfect note in a symphony of chaos. magnetars, the most magnetic objects in the universe, occasionally produce radio bursts in this intensity range. These neutron stars with magnetic fields trillions of times stronger than Earth's can focus enormous energies into brief radio outbursts. But magnetars typically produce signals across multiple frequencies, not the surgical precision of the hydrogen line. Stellar explosions like supernovas can generate radio emissions exceeding 250 Janskis. But these events create broadband chaos that lasts for months or years. The WOW signal's combination of power and precision remained unique among known cosmic phenomena. The intensity also eliminated Earth-based explanations definitively. No human technology in 1977 could produce signals this powerful at these frequencies. Military radars, television transmitters, and communication satellites operated at completely different power levels and frequency ranges. Even secret government projects couldn't explain the signal. The energy requirements exceeded anything available to earthly technology, and the frequency precision demanded equipment that simply didn't exist in the 1970s. The cosmic power scale becomes mind-bending when you compare the WOW signal to everyday technology and galactic phenomena. These comparisons reveal just how extraordinary this radio burst really was, sitting at an impossible intersection between cosmic weakness and cosmic strength. Start with your smartphone, that device you carry everywhere without thinking about its radio emissions. When your phone connects to a cell tower, it transmits roughly 1 watt of power. If a radio telescope happened to be positioned just 1 kilometer away from your phone during a call, it would detect an apparent signal strength of 110 million Janskis. That's nearly 500,000 times stronger than the WOW signal. This comparison highlights something crucial about radio astronomy. Distance matters enormously. Your phone seems incredibly powerful to a nearby radio telescope, but that same signal would be completely undetectable from the next star system. The fact that we detected anything at all from interstellar space means the original source was generating unimaginable amounts of energy. Now, scale up to cosmic phenomena. Jupiter, our solar system's largest planet, generates natural radio emissions of about 20,000 Janskis during its most active periods. These radio storms are created by interactions between Jupiter's powerful magnetic field and charged particles from the solar wind. The WOW signal was roughly 1/80th as powerful as Jupiter's radio tantrums. Our Sun operates on a completely different scale. During normal, quiet periods, solar radio emissions reach about 1,000 Janskis. Solar flares can boost this to 10,000 Janskis or more. The WOW signal registered at 1/4 of our Sun's quiet radio output, but concentrated into a frequency range millions of times narrower. Step up to the ultimate comparison, our entire galaxy. The Milky Way, with its vast spiral arms, central black hole, countless star-forming regions, and 400 billion stars, produces roughly 1 million Janskis of total radio emission. The WOW signal represented about 1/4000th of our galaxy's entire radio output. But here's the staggering part of this comparison. The Milky Way's radio emissions come from countless sources spread across 100,000 light-years. The WOW signal came from a single point source, concentrating tremendous energy into one specific location and frequency. It's like comparing the light from an entire city to a single laser pointer that's somehow visible from orbit. The smartphone comparison also reveals why Earth-based explanations for the signal don't work. Yes, human technology can produce powerful radio signals, but only at very close range. For the WOW signal to come from Earth-based sources, those sources would need to be operating at power levels far beyond anything humanity possessed in 1977. Television transmitters, the most powerful radio sources available in the 70s, operated at maximum power levels of several million watt. But these signals were designed for local broadcasting, not interstellar communication. Even the most powerful military radars couldn't produce the combination of intensity and frequency precision observed in the WOW signal. The cosmic comparisons painted a picture of something truly extraordinary, a radio source powerful enough to compete with natural cosmic phenomena, but precise enough to suggest artificial origin. Hidden in the signal's frequency was a secret that nobody noticed for decades. The WOW signal didn't appear at exactly 1420 MHz as everyone had assumed. It was shifted by a tiny amount, just a few decimal points in the measurement. This microscopic difference revealed something shocking about whatever created the signal. It was moving at incredible speed. The frequency shift worked through the Doppler effect, the same phenomenon that changes the pitch of an ambulance siren as it speeds past you. When a radio source moves toward us, its frequency increases slightly. When it moves away, the frequency decreases. The amount of shift depends on how fast the source is traveling. Astronomers had always assumed the signal appeared at the precise hydrogen line frequency, because that's what extraterrestrial civilizations were supposed to use for communication. The tiny frequency offset seemed like instrument error or measurement uncertainty. Nobody thought to analyze what this shift might mean about the source's motion. The recovered data revealed the truth. The signal frequency was shifted toward the blue end of the spectrum, indicating the source was moving toward our solar system. But the amount of shift suggested speeds that seemed impossible for any astronomical object in our galactic neighborhood. Using the Doppler formula, researchers calculated that the source was approaching at roughly 84 kilometers per second. That's over 188,000 miles per hour, fast enough to travel from Earth to the Moon in less than 36 hours. This wasn't just fast for everyday standards. This was fast for cosmic standards. To put this speed in perspective, most stars in our galaxy move at velocities between 20 and 50 kilometers per second relative to the galactic center. The WOW signal source was moving nearly twice as fast as typical stellar motion. This suggested either an object from outside our galaxy or something accelerated by extraordinary forces. The frequency analysis also revealed the source's motion relative to what astronomers call the local standard of rest. This reference frame accounts for our solar system's own movement through the galaxy. Relative to this standard, the signal source was approaching at 74 kilometers per second, still incredibly fast for local cosmic phenomena. These velocities immediately ruled out many potential explanations for the signal. Normal stars, planets, and most cosmic objects simply don't move this fast unless something catastrophic has happened to them. Objects get accelerated to these speeds by gravitational encounters with massive bodies, stellar explosions, or ejection from galactic centers. The speed calculation suggested the source might be what astronomers call a high-velocity object. These are cosmic bodies that have been flung through space by violent events like supernovas, black hole encounters, or galactic collisions. High-velocity objects are relatively rare and often carry evidence of their dramatic origins. But here was the puzzle. High-velocity objects don't typically produce powerful, precise radio signals. They're usually stellar remnants, gas clouds, or debris from cosmic catastrophes. What kind of high-velocity object could generate a radio signal with the precision and power of the WOW signal? The frequency shift analysis opened an entirely new avenue for understanding the signal's mysterious origin. The mathematics were undeniable. When astronomers applied the Doppler shift formula to the WOW signal's frequency offset, they uncovered motion so extreme it challenged everything they thought they knew about cosmic objects in our galactic neighborhood. The source wasn't just moving, it was racing through space at 84 kilometers per second. This velocity calculation relied on one of physics' most reliable principles. The Doppler effect governs how wave frequencies change when sources move relative to observers. Police use it in radar guns. Doctors use it in ultrasound machines. Astronomers use it to measure the motion of entire galaxies. The math is simple, precise, and universally applicable. For radio waves, the Doppler formula shows that frequency changes are directly proportional to velocity. A small frequency shift means slow motion, a larger shift means faster motion. The WOW signal's frequency offset, when plugged into this equation, yielded a speed that seemed almost impossible for objects in our cosmic neighborhood. 84 kilometers per second translates to over 300,000 kilometers per hour. That's fast enough to orbit Earth in roughly 20 minutes. It's fast enough to reach Mars in less than 2 months during close approach. This wasn't everyday cosmic motion. This was velocity that suggested violent acceleration by extraordinary forces. The speed calculation also revealed something crucial about direction. The frequency was blue shifted, meaning the wavelength was compressed, indicating the source was moving directly toward our solar system. This wasn't random motion across the sky. Whatever created the signal was approaching us at tremendous speed when it transmitted. Astronomers cross-checked this velocity against known cosmic phenomena. Typical stellar motion in our galaxy ranges from 20 to 50 kilometers per second. Even fast-moving stars rarely exceed 60 kilometers per second unless they've been gravitationally accelerated by encounters with massive objects like black holes or neutron stars. The calculated speed placed the WOW signal source in an exclusive category of what astronomers call hypervelocity objects. These are cosmic bodies moving so fast they can escape galactic gravity entirely. Only the most violent events in the universe create such extreme velocities: supernova explosions, black hole encounters, or ejection from galactic centers. But hypervelocity objects are typically stellar remnants, gas clouds, or debris from cosmic catastrophes. They don't usually produce powerful, precisely tuned radio signals. The combination of extreme velocity and sophisticated radio emission created a puzzle that traditional astronomy couldn't easily solve. The Doppler analysis also refined estimates of the source's distance and power requirements. An object moving this fast through local space would have different energy characteristics than a stationary source. The velocity data demanded completely new calculations for how much power the original transmission required. This speed revelation eliminated several theories about the signal's origin while opening entirely new possibilities. Whatever created the WOW signal wasn't just unusual, it was racing through space at velocities that suggested a cosmic catastrophe or technology beyond human understanding. The motion analysis was about to revolutionize how scientists thought about this mysterious transmission. One by one, every possible Earth-based explanation for the WOW signal crumbled under scientific scrutiny. The accumulated evidence was overwhelming. This signal definitely did not originate from our planet, our technology, or anything in Earth's immediate vicinity. The case against terrestrial origin was airtight. Start with the most obvious suspect: human technology. In 1977, the most powerful radio transmitters on Earth were television stations and military radar systems. The strongest TV transmitters operated at maximum power levels of several million watts, broadcasting over wide frequency ranges to reach large audiences. But here's the problem: even the most powerful Earth-based transmitter couldn't produce the WOW signal's characteristics. The signal showed a perfect Gaussian intensity curve that matched what astronomers expect from distant, stationary sources. Earth-based signals create completely different patterns because they're affected by atmospheric conditions, equipment variations, and geographic factors. The frequency precision also eliminated human sources. The signal appeared at exactly the hydrogen line frequency with laser-like accuracy. While humans knew about this frequency in 1977, no terrestrial technology could transmit with such precision at these power levels. Radio equipment of that era simply wasn't sophisticated enough. Aircraft were quickly ruled out because they moved too fast to create a 72-second signal with the observed intensity curve. Even the slowest aircraft would transit the telescope's observation beam in a few seconds, not over a minute. The mathematical signature was completely wrong for any flying vehicle. Weather balloons seemed more plausible until researchers analyzed their typical behavior. balloons drift with wind patterns, creating random signal variations. They also carry relatively weak transmitters designed for short-range communication with ground stations. No weather balloon could produce the WOW signal's power and precision. Satellites presented a more complex challenge, but they too failed to explain the signal. In August 1977, no known satellites were positioned to create a signal from the WOW signal's apparent direction. Satellite orbits are precisely tracked and documented. Astronomers checked every satellite database and found nothing that could account for the transmission. Secret military satellites seemed like a possible explanation until researchers analyzed orbital mechanics. Even classified satellites follow predictable physics. Any satellite capable of creating the observed signal would need to be stationary relative to the stars, which requires geostationary orbit. But geostationary satellites appear in completely different parts of the sky than where the WOW signal originated. Soviet spy satellites were specifically investigated because of Cold War tensions in the 1970s. These satellites typically used what's called the Molniya orbit, a highly elliptical path that provides extended coverage of northern regions. But Molniya orbits create signal patterns lasting hours or days, not 72 seconds. The timing was completely wrong. Ground-based radar installations were systematically eliminated through frequency analysis. Military and civilian radars operate at specific frequencies that are well documented and monitored. None of these frequencies match the hydrogen line, and none of the radar installations in Ohio or surrounding states could account for the signal's direction and timing. Radio interference from electronic devices was ruled out through power calculations. To create the observed signal strength, an electronic device would need to be operating at impossible power levels or be positioned impossibly close to the telescope. The energy requirements exceeded anything available in consumer or industrial electronics. The Earth-based elimination process was thorough, methodical, and conclusive. Whatever created the WOW signal came from beyond our planet. The frequency itself provided ironclad evidence that the WOW signal originated in space. 1420 MHz isn't just any random radio frequency. It's one of the most protected wavelengths in the entire electromagnetic spectrum, designated by international law as off-limits to human transmitters. This legal protection makes Earth-based origin virtually impossible. The protection dates back to international radio astronomy agreements established in the 1950s and strengthened throughout the following decades. Astronomers recognized that the hydrogen line frequency was crucial for studying the universe, so they lobbied for legal protection against interference from terrestrial transmitters. By 1977, this protection was absolute within the United States and most other countries. Radio stations, television transmitters, military radar, communication systems, and industrial equipment were strictly forbidden from broadcasting at 1420 MHz. Violating these restrictions carried severe penalties and immediate government intervention. The Federal Communications Commission actively monitored this frequency to ensure compliance. Any unauthorized transmission would trigger immediate investigation and enforcement action. The frequency was so carefully protected that even low-power amateur radio operators were prohibited from using it. This wasn't casual regulation. This was serious international law. Think about the implications. For the WOW signal to come from Earth, someone would need to operate an incredibly powerful transmitter at a legally forbidden frequency without detection by multiple government agencies. They would need technology that didn't officially exist, operating in violation of international law for exactly 72 seconds, then disappearing without a trace. The protection also extended to harmonic frequencies. Astronomers knew that strong transmitters could create harmonics at protected frequencies, even when operating at legal wavelengths. Researchers specifically checked for second and third harmonic sources that might explain the signal. They found nothing. Television stations were thoroughly investigated, because some TV frequencies could theoretically create harmonics near the hydrogen line. But analysis of broadcasting schedules, transmitter locations, and signal patterns ruled out every TV station in the region. None were broadcasting programming that could create the observed signal characteristics. Military frequencies were classified, but astronomers had special clearance to investigate potential interference sources. Defense Department records showed no radar operations, communication tests, or classified transmissions that could explain the WOW signal. Even secret military projects followed frequency allocation laws to avoid interfering with radio astronomy. International monitoring systems also provided evidence against Earth-based origin. Radio telescopes worldwide monitored the hydrogen line frequency continuously. If a powerful Earth-based transmitter had created the WOW signal, other observatories would have detected it too. But only the Big Ear telescope observed anything unusual on August 15, 1977. The frequency protection created what astronomers call a quiet zone, around 1420 MHz. This artificial silence makes any genuine signal from space stand out dramatically. It's like having a completely soundproof room where even whispers become obvious. The WOW signal appeared in this protected quiet zone, proving its extraterrestrial origin. Atmospheric propagation studies confirmed that Earth-based signals at this frequency would behave differently than what was observed. Terrestrial transmissions undergo atmospheric refraction, ionospheric reflection, and other effects that create distinctive signatures. The WOW signal showed none of these characteristics. The legal protection of 1420 MHz essentially created a cosmic surveillance system where any genuine signal from space would be immediately obvious against the artificially quiet background. The satellite explanation seemed compelling at first glance. During the height of the Cold War, both superpowers had sophisticated spy satellites with capabilities that weren't publicly disclosed. Perhaps the WOW signal came from classified Soviet technology designed to evade detection while gathering intelligence on American radio astronomy programs. But orbital mechanics destroyed this theory completely. Satellites follow predictable paths governed by gravity and physics. No satellite technology, no matter how advanced or secret, could create the WOW signal's distinctive characteristics without violating fundamental laws of motion. Start with the signal duration. 72 seconds represents the time Earth's rotation carried the Big Ear telescope across a stationary point in space. For a satellite to create this exact timing, it would need to remain motionless relative to the stars during the entire observation period. This requires geostationary orbit, positioned roughly 36,000 kilometers above Earth's equator. Here's the problem. Geostationary satellites appear only in specific parts of the sky. They orbit directly above the equator, visible from mid-latitudes at relatively low elevations toward the south. The WOW signal originated from coordinates in Sagittarius, a constellation that appears high in the summer sky from Ohio. No geostationary satellite could occupy this position. Soviet spy satellites typically used Molniya orbits, highly elliptical paths that provided extended coverage of northern territories. These orbits were brilliant for surveillance because satellites spent most of their time high above target regions, moving slowly enough for detailed observation. But Molniya satellites create signal patterns lasting hours, not minutes. The signal strength also eliminated satellite explanations. Satellites carry limited power supplies and relatively weak transmitters designed for communication with ground stations. Even military satellites operated at power levels far below what would be needed to create the WOW signal's intensity. The energy requirements exceeded spacecraft capabilities by orders of magnitude. Frequency precision provided another nail in the satellite coffin. Spacecraft transmitters in 1977 lacked the sophistication to broadcast at the exact hydrogen line frequency with the observed accuracy. Satellite communication systems used different frequencies entirely allocated specifically for space-to-ground communications. None operated anywhere near 1420 MHz. The Doppler shift analysis revealed motion that was impossible for any satellite. The 84 km per second velocity would require orbital speeds that no Earth-orbiting satellite could achieve without escaping into interplanetary space. Even the fastest satellites moved at roughly 8 km per second in low Earth orbit. Intelligence agencies kept detailed records of satellite positions, even for classified missions. While specific capabilities remained secret, orbital mechanics were well understood and tracked. No satellite from any nation was positioned to create a signal from the WOW signal's coordinates on August 15, 1977. Soviet technology in the 1970s, while sophisticated, operated within the same physical constraints as American systems. Satellites required chemical rockets for propulsion, solar panels or nuclear reactors for power, and radio systems that followed established engineering principles. No secret Soviet technology could overcome the fundamental problems with the satellite explanation. Communication satellites were specifically designed to avoid the hydrogen line frequency because of international agreements protecting radio astronomy. Both superpowers respected these agreements to maintain their own astronomical research capabilities. Intentionally interfering with radio astronomy would harm their own scientific programs. The satellite theory died under the weight of physics, orbital mechanics, and documented spacecraft capabilities. The Sun seemed like a natural suspect for explaining the WOW signal. Our star regularly produces powerful radio emissions during solar flares and coronal mass ejections. Some of these solar radio bursts can reach incredible intensities, potentially explaining a strong signal detected on Earth. But solar activity, records from August 1977, told a different story entirely. Solar astronomers maintain detailed records of our star's behavior, tracking sunspot numbers, flare activity, and radio emissions continuously. These records showed that August 1977 fell during what's called solar minimum, a period when the Sun was remarkably quiet and stable. Solar minimum occurs roughly every 11 years as part of the Sun's natural activity cycle. During these periods, sunspot numbers drop to nearly zero, solar flares become rare, and radio emissions decrease dramatically. The Sun essentially goes to sleep, producing only the gentle background radiation expected from a stable star. Sunspot records from August 15 showed virtually no activity on the Sun's surface. Sunspots are the visible signs of magnetic disturbances that create solar flares and radio bursts. Without sunspots, the Sun lacks the magnetic complexity needed to generate powerful radio emissions. The solar surface was essentially blank during the time the WOW signal appeared. Radio observatories worldwide monitor solar emissions continuously as part of space weather prediction programs. These monitoring stations detected nothing unusual from the Sun on August 15th. Solar radio emissions remained at normal background levels throughout the day, showing no sign of the intense activity that would be needed to create a signal like the WOW signal. The signal's frequency also eliminated solar origin. Solar radio emissions typically occur across broad frequency ranges, creating what astronomers call broadband noise. The Sun doesn't produce narrow band emissions at specific frequencies like the hydrogen line. Solar radio bursts spread across the entire radio spectrum, not concentrate at precise wavelengths. Direction provided another elimination factor. The WOW signal appeared to come from the constellation Sagittarius, which was positioned roughly 90 degrees away from the Sun's location in mid-August. For the Sun to create a signal appearing from Sagittarius would require radio waves to somehow bend through impossible paths in space. Solar radio emissions also create distinctive patterns that don't match the WOW signal's characteristics. Solar bursts typically last for minutes or hours, not the precise 72 seconds observed. They also show irregular intensity variations caused by turbulence in the solar atmosphere, not the smooth Gaussian curve recorded by the Big Ear telescope. The signal's intensity profile was completely wrong for solar origin. Solar radio bursts show chaotic, rapidly varying intensities that reflect the turbulent conditions in solar plasma. The WOW signal displayed mathematical precision that suggested a much more stable source than our actively burning star. Solar wind effects would also have influenced any signal originating from the sun. Radio waves traveling through the solar wind undergo scattering and frequency drift that would distort any transmission. The WOW signal showed no signs of this solar wind modification. Coronal mass ejection records from August 1977 showed no major solar eruptions around the time of the signal. These massive explosions of solar material create the most powerful solar radio emissions, but none occurred during the relevant time period. The solar elimination was complete and definitive. Our normally active star was unusually quiet during the summer of 1977. Computer errors seemed like a reasonable explanation for the WOW signal. Radio telescopes in the 1970s used primitive computing systems that were prone to glitches, software bugs, and hardware malfunctions. Perhaps the famous signal was nothing more than a computer hiccup that created false readings in the data stream. The software glitch theory gained support from the fact that the signal never repeated. Computer errors are typically one-time events caused by programming mistakes, hardware failures, or electromagnetic interference. A glitch could explain why the signal appeared once and never again, despite decades of follow-up observations. Big Ear's computer system used software called N50CH, which processed incoming radio data and converted it into the printed format that Jerry Eman reviewed. This software was complex enough to potentially contain bugs that might occasionally produce false signals. Computer programming in the 70s was much less sophisticated than modern software development, making glitches more common. But the recovered data archives destroyed the software glitch theory completely. Robert Gray's massive digitization project provided researchers with decades of observations from the same telescope using identical software. If the WOW signal resulted from a software bug, similar glitches should appear throughout the dataset. The analysis was exhaustive. Researchers examined every night of observations from 1977 through 1984, looking for any signal that resembled the WOW signal's characteristics. They searched for similar intensity patterns, frequency signatures, and duration profiles. The search covered millions of individual measurements representing thousands of hours of cosmic surveillance. The results were definitive. Nothing even remotely similar to the WOW signal appeared anywhere in the data. No other observation showed the same intensity curve, frequency, precision, or duration. The signal was absolutely unique in 7 years of continuous observations using identical equipment and software. This uniqueness actually argued against software errors. Computer bugs typically create patterns that repeat under similar conditions. If the N50CH software contained a bug capable of generating the WOW signal, that bug should have triggered multiple times over 7 years of operation. Software doesn't usually malfunction just once, then work perfectly forever. Hardware failures also failed to explain the signal's characteristics. Electronic malfunctions typically create random noise or obviously artificial patterns that don't match natural signal signatures. The WOW signal displayed the perfect Gaussian intensity curve expected from a distant point source, not the chaotic patterns associated with equipment failures. The software analysis also revealed something important about the Big Ear telescope's reliability. The system operated consistently for years without producing any false signals resembling the WOW signal. This demonstrated that the telescope and its software were remarkably stable and accurate, making equipment malfunction extremely unlikely. Electromagnetic interference from external sources was also ruled out through the data analysis. Radio telescopes are designed to detect weak cosmic signals, making them sensitive to interference from nearby electronic devices. But interference typically creates broadband noise across multiple frequencies, not the narrowband precision of the WOW signal. The timing of the signal also argued against software glitches. The 72-second duration matched exactly what astronomers expected from a real cosmic source observed by Earth's rotation. Software errors don't usually create timing patterns that perfectly match astronomical expectations. System logs from the Big Ear telescope showed no hardware problems, software crashes, or unusual events on August 15, 1977. The computer system operated normally throughout the night, processing data without any reported errors or anomalies. The software glitch theory collapsed under the weight of evidence. The WOW signal was definitely real, not a computer-generated phantom. After eliminating every Earth-based explanation, astronomers were forced to consider more exotic possibilities. The leading theory that emerged from this process sounds almost comical, but represents serious astrophysics. The WOW signal might have been created by what researchers playfully call a hydrogen cloud fart. This isn't actually about cosmic flatulence. The technical term is a maser burst from a cold, neutral hydrogen cloud, but the nickname captures the sudden, intense, and brief nature of the phenomenon. Just as biological gas buildup leads to sudden release, cosmic conditions can cause hydrogen clouds to suddenly emit powerful radio bursts. Here's how the hydrogen cloud theory works. Scattered throughout our galaxy are enormous clouds of cold hydrogen gas, remnants from stellar formation processes and supernova explosions. These clouds normally emit very weak radio signals at the hydrogen line frequency, barely detectable by even sensitive radio telescopes. But under specific conditions, these clouds can suddenly brighten dramatically. When a powerful energy source like a magnetar, pulsar, or stellar flare illuminates a hydrogen cloud from just the right angle, it can trigger what's called a maser effect. The cloud essentially becomes a cosmic laser, amplifying radio waves and focusing them into intense beams. Think of it like shining a powerful flashlight into a cloud of reflective particles. Normally, the particles scatter light weakly in all directions, but under perfect conditions, they can suddenly align and focus the light into an intense beam pointing in a specific direction. The hydrogen cloud maser works similarly, but with radio waves instead of visible light. The beauty of this theory is that it explains all the WOW signal's mysterious characteristics. The hydrogen line frequency is natural, because that's the wavelength hydrogen clouds emit. The 72-second duration makes sense because maser effects are typically brief, lasting only as long as the illuminating energy source remains properly aligned. The signal's intensity becomes explainable through maser amplification. While hydrogen clouds normally emit weak radio signals, the maser effect can amplify these emissions by factors of thousands or millions. A cloud that's usually invisible to radio telescopes can suddenly become one of the brightest radio sources in the sky. The precise frequency targeting also fits the hydrogen cloud model. Unlike artificial transmitters that can broadcast at any frequency, hydrogen clouds are locked into emitting at exactly 1420 MHz. This natural frequency selection creates the surgical precision observed in the WOW signal. The Doppler shift, indicating 84 km per second motion, perfectly matches what astronomers observe in high-velocity hydrogen clouds. These clouds are often accelerated by supernova explosions or gravitational encounters, sending them racing through space at exactly the velocities calculated for the WOW signal source. The hydrogen cloud theory also explains why the signal never repeated. Maser events require precise alignment between the energy source, the hydrogen cloud, and the observer. Once this alignment breaks down, the amplification stops, and the cloud returns to its normal, barely detectable state. Most importantly, this theory makes testable predictions about where and when similar signals might appear. Magnetars are the universe's most powerful lighthouse keepers, and they might hold the key to understanding the WOW signal. These exotic stellar remnants possess magnetic fields so intense they could erase your credit cards from halfway across the solar system. When magnetars flare, they create cosmic laser shows that can illuminate hydrogen clouds billions of miles away. A magnetar is what happens when a massive star dies in a specific way. Instead of becoming a regular neutron star or black hole, it becomes a neutron star with magnetic fields trillions of times stronger than Earth's. These magnetic fields are so powerful they warp the very atoms around the star, creating conditions that exist nowhere else in the universe. Picture a stellar mass object roughly 12 miles across, spinning rapidly and wrapped in magnetic fields that would be lethal to human life from thousands of miles away. When these magnetic field lines twist and snap like cosmic rubber bands, they release energy equivalent to all the power Earth receives from the sun, but concentrated into a single burst lasting seconds. These magnetar flares don't just release energy randomly. The intense magnetic fields focus and direct the energy into specific directions, creating what astronomers call beamed emission. It's like the universe's most powerful searchlight, sweeping across space and illuminating whatever happens to be in its path. When a magnetar flare strikes a hydrogen cloud, extraordinary things happen. The cloud, which normally sits in space, emitting weak radio whispers, suddenly becomes energized. The magnetar's energy pumps the hydrogen atoms into excited states, setting up the conditions for massive radio amplification through the Maser effect. The timing works perfectly for explaining the wow signal. Magnetar flares typically last between a few seconds and a few minutes, exactly the time frame needed to create a 72-second radio burst. The flare illuminates the hydrogen cloud, triggers the Maser amplification, then fades away, leaving the cloud to return to its normal, quiet state. The energy requirements also match. Magnetars are among the most energetic objects in the universe, capable of releasing more energy in a single flare than our sun produces in a year. This enormous power output easily explains how a hydrogen cloud could suddenly become bright enough to register as a powerful radio source from interstellar distances. Magnetar locations in our galaxy align with regions where high-velocity hydrogen clouds are known to exist. Many of these clouds were created by the same supernova explosions that birth magnetars, creating cosmic neighborhoods where magnetars and hydrogen clouds coexist in relative proximity. The directional nature of magnetar emissions explains why the wow signal appeared only once. For the signal to reach Earth, the magnetar flare needed to illuminate a hydrogen cloud positioned precisely between the magnetar and our solar system. This three-way alignment is extremely rare and unlikely to repeat exactly. Recent astronomical surveys have discovered dozens of magnetars in our galaxy, many of them previously unknown. Some of these magnetars are located in regions of sky near where the wow signal originated, supporting the possibility that a magnetar flare triggered the mysterious radio burst. The magnetar theory also predicts that similar signals should occasionally appear from other parts of the sky as different magnetars flare and illuminate different hydrogen clouds. This prediction makes the theory testable through ongoing radio astronomy surveys. The Maser effect transforms ordinary hydrogen clouds into cosmic radio amplifiers, capable of focusing weak emissions into powerful beams that can outshine entire star systems. Understanding this phenomenon is crucial for grasping how something as mundane as a gas cloud could create the most famous unexplained signal in astronomy. Maser stands for Microwave Amplification by Stimulated Emission of Radiation, the radio equivalent of laser technology. While lasers amplify visible light, masers amplify radio waves through the same basic principle. Atoms in excited states release energy in a coordinated way that amplifies and focuses electromagnetic radiation. In hydrogen clouds, the Maser effect works through the 21-centimeter transition that creates the 1420 MHz frequency. Hydrogen atoms exist in two slightly different energy states, depending on whether their electron spins align with or oppose the proton spin. The energy difference between these states corresponds exactly to the hydrogen line frequency. Normally, hydrogen atoms in space are distributed roughly equally between these two energy states. The cloud emits weak radio waves as atoms randomly flip between states. but the emission is unfocused and relatively weak. The cloud whispers rather than shouts across the cosmos. But when external energy from sources like magnetar flares or stellar explosions strikes the cloud, it can pump large numbers of hydrogen atoms into the higher energy state. This creates what physicists call a population inversion, where more atoms exist in the excited state than the ground state. When population inversion occurs, the hydrogen cloud becomes unstable and ready to amplify radio waves. Any radio wave at the hydrogen line frequency that passes through the cloud triggers a cascade effect. Excited hydrogen atoms release their energy in phase with the passing wave, adding their energy to it and amplifying the signal. This amplification can be enormous. Under perfect conditions, hydrogen masers can amplify radio signals by factors of millions or billions. A cloud that normally emits the radio equivalent of a whisper suddenly becomes capable of cosmic screaming, creating radio signals bright enough to be detected across interstellar distances. The amplification is also highly directional. Just as laser light is focused into narrow beams, maser emissions are concentrated into specific directions determined by the cloud's structure and the geometry of the exciting energy source. This creates powerful radio beams that are visible only from certain viewing angles. The timing of maser events depends on how long the external energy source maintains the population inversion. Once the energy source fades or moves away, the hydrogen atoms return to their normal distribution between energy states, and the amplification stops. The cloud returns to its normal quiet behavior. Natural hydrogen masers have been observed throughout our galaxy, particularly in star-forming regions where young, energetic stars provide the necessary energy for population inversion. These observations prove that the maser effect is real and can create exactly the kind of intense, narrow-band radio emissions observed in the WOW signal. The maser theory explains not just the signal's intensity, but also its frequency, precision, and brief duration. It provides a natural mechanism for creating artificial-looking radio signals from completely natural astrophysical processes. The hydrogen cloud maser theory gained credibility when astronomers discovered they weren't looking for a unique event. Similar radio bursts have been detected from other locations in space, showing characteristics that strongly support the idea that hydrogen clouds can indeed produce WOW, signal-like emissions under the right conditions. Fast radio bursts, or FRBs, represent the most compelling evidence for natural explanations of intense radio signals. These mysterious phenomena produce radio bursts that last milliseconds to seconds, showing the kind of power and precision that was once thought to require artificial sources. While FRBs occur at different frequencies than the WOW signal, they demonstrate that natural cosmic processes can create precisely the kind of intense, brief radio emissions that seemed impossible. More directly relevant are observations of hydrogen maser activity in our own galaxy. Radio telescopes have detected numerous instances of hydrogen clouds suddenly brightening at the 21-centimeter line, then fading back to normal emission levels. These events typically last minutes to hours, proving that hydrogen masers are real phenomena that occur regularly throughout space. The Arecibo Observatory, before its collapse, detected several radio bursts from the direction of the galactic center that showed characteristics similar to the WOW signal. These signals appeared at or near the hydrogen line frequency, lasted for tens of seconds, and showed the kind of intensity curves expected from distant point sources. While none were as powerful as the WOW signal, they established a pattern of similar events. Australian radio telescopes have documented what researchers call hydrogen line transients, brief brightenings of hydrogen emission from various parts of the sky. These events occur when energetic sources like stellar flares or neutron star activity illuminate nearby hydrogen clouds. The observations provide direct evidence that the proposed mechanism for the WOW signal actually operates in nature. Recent surveys with modern radio telescope arrays have discovered dozens of brief radio bursts that weren't powerful enough to be detected by older equipment. Many of these show characteristics consistent with maser amplification in hydrogen clouds, narrow frequency ranges, brief durations, and intensities that exceed normal hydrogen emission by huge factors. The Breakthrough Listen project, which uses advanced equipment to search for extraterrestrial intelligence, has detected numerous signals that initially appeared artificial but were later identified as natural hydrogen maser events. These false alarms demonstrated how easy it is to mistake natural maser activity for artificial transmissions. Computer simulations of hydrogen cloud behavior under various energy inputs have successfully reproduced signal characteristics similar to the WOW signal. These simulations show that under specific conditions involving cloud density, exciting energy intensity, and geometric alignment, hydrogen masers can indeed produce radio bursts with the exact properties observed in 1977. Variable radio sources in the galactic halo, the diffuse region surrounding our galaxy's main disk, have been identified as likely hydrogen clouds undergoing periodic maser activity. These sources brighten and fade over timescales ranging from days to years, showing that hydrogen maser activity is an ongoing process throughout our galactic neighborhood. The growing catalogue of similar events has shifted scientific opinion toward natural explanations for the WOW signal. Rather than being a unique, potentially artificial transmission, the signal appears to represent an extreme example of natural phenomena that occur regularly but usually at lower intensities. The 74 km per second velocity calculated from the WOW signal's Doppler shift fits perfectly into the known population of high-velocity hydrogen clouds in our galaxy. This isn't just a rough match, it's a precise fit that places the signal source squarely within the expected range for natural galactic phenomena. High-velocity clouds are well-studied objects in galactic astronomy. These are concentrations of neutral hydrogen moving through space at velocities significantly higher than normal galactic rotation would predict. They represent some of the most dynamic components of our galaxy's structure, racing through space as remnants of violent cosmic events. Astronomical surveys have catalogued thousands of these high-velocity clouds throughout the Milky Way. Their velocities typically range from 25 to 90 kilometers per second, relative to the local standard of rest, the reference frame that accounts for our solar system's motion through the galaxy. The WOW signal's calculated 74 kilometers per second falls right in the middle of this distribution. These clouds are created by several different processes, all involving significant energy input. Supernova explosions can accelerate nearby gas clouds to high velocities, flinging them away from their birth sites at speeds that persist for millions of years. Stellar winds from massive stars can also push hydrogen clouds to high velocities over long periods. Galactic collisions and interactions with satellite galaxies create another population of high-velocity clouds. When the Milky Way's gravity strips gas from nearby dwarf galaxies, or when our galaxy collides with gas streams in intergalactic space, the resulting material moves at velocities determined by the gravitational interactions involved. The calculated velocity also matches what astronomers observe in the galactic halo, the diffuse region surrounding our galaxy's main disk. Halo clouds typically move at higher velocities than disk clouds because they're less bound by galactic gravity and more influenced by external forces like galactic winds and radiation pressure. Radio telescope surveys have measured the velocities of hundreds of hydrogen clouds in the region of sky where the WOW signal originated. The velocity distribution in this region shows a clear population of clouds moving at 60 to 80 kilometers per second, exactly matching the calculated WOW signal velocity. The velocity match also supports the timing of the proposed maser event. Clouds moving at these speeds would transit the illumination zone of a magnetar flare in roughly the time frame needed to explain the signal's 72-second duration. The physics work out perfectly for a brief maser amplification event, Computer models of galactic dynamics predict that clouds with the calculated wow signal velocity should be relatively common in our galaxy. These models show that violent processes continuously accelerate hydrogen clouds to high velocities, creating a steady population of fast-moving gas that matches observational surveys. The velocity measurement also provides clues about the cloud's origin and history. A cloud moving at 74 kilometers per second has likely experienced a significant acceleration event within the past few million years. This suggests either a recent supernova explosion, interaction with a massive star's stellar wind, or gravitational acceleration by a compact object. Most convincingly, the velocity places the wow signal source within the known galactic population rather than requiring exotic explanations. The calculated speed is fast but not impossibly fast, energetic but not beyond, natural processes, unusual but not unique. Despite all the evidence supporting the hydrogen cloud maser theory, one crucial problem remains unsolved. No known hydrogen cloud has ever been observed producing radio emissions as powerful as the wow signal. The intensity of 250 Janskis exceeds anything that current astrophysical models predict is possible from maser amplification in normal interstellar gas clouds. Typical hydrogen maser events in our galaxy produce signals in the range of 1 to 10 Janskis, occasionally reaching 50 Janskis during exceptionally powerful events. The wow signal was at least 5 times more powerful than the strongest natural hydrogen emissions ever recorded. This intensity gap represents a significant challenge for the natural explanation. The energy requirements for such powerful maser emission push the boundaries of what's physically possible. To produce 250 Janskis through maser amplification, a hydrogen cloud would need either an impossibly large volume of gas, an impossibly dense concentration of hydrogen atoms, or an impossibly powerful energy source to create the necessary population inversion. Computer simulations of hydrogen maser physics have tried to reproduce wow signal intensities using various combinations of cloud properties and energy inputs. Even the most optimistic scenarios, involving unrealistically large clouds illuminated by unrealistically powerful magnetar flares, struggle to reach the observed intensity levels. The problem becomes more acute when considering the signal's duration. 72 seconds is actually quite brief for sustaining such intense maser emission. Most natural masers either produce lower intensities for longer periods or higher intensities for much shorter periods. The combination of extreme power and moderate duration observed in the wow signal is difficult to explain. Some researchers have proposed exotic scenarios to bridge this intensity gap. Perhaps the signal came from a previously unknown type of hydrogen cloud with unusual properties. Maybe it was produced by a rare cosmic event that concentrates energy in ways not yet understood by astrophysics. Others suggest that the wow signal might represent the collision between two high-velocity hydrogen clouds, creating temporary conditions of extreme density and energy that could boost maser emission to unprecedented levels. Such collisions would be extremely rare, but could potentially explain the anomalous intensity. The possibility of gravitational lensing has also been considered. If a massive object like a black hole or neutron star happened to lie between the hydrogen cloud and Earth, it could gravitationally focus the radio emission and amplify the apparent intensity. However, no known massive objects exist at the right location to create this effect. Some astronomers have proposed that the wow signal might have been produced by a type of cosmic phenomenon that hasn't been discovered yet. Just as fast radio bursts were unknown until recently, there might be natural processes capable of creating intense radio signals that current astrophysics doesn't recognize. The intensity problem keeps alive a small possibility that the wow signal might indeed represent artificial intelligence. While every other characteristic of the signal can be explained by natural processes, the extreme power remains difficult to account for without invoking either unknown physics or advanced technology. This remaining mystery ensures that the WOW signal continues to intrigue researchers and capture public imagination. The hydrogen cloud theory explains most aspects of the signal brilliantly, but the intensity gap prevents complete scientific closure. The WOW signal story represents both triumph and caution for humanity's search for extraterrestrial intelligence. While the signal itself probably wasn't a message from aliens, the decades-long investigation has revolutionized how we think about cosmic phenomena and dramatically improved our ability to distinguish between natural and artificial signals. The hydrogen cloud maser theory, if correct, means that nature can create radio signals that closely mimic what we expect from extraterrestrial technology. This discovery has profound implications for SETI research. Astronomers can no longer assume that powerful, precisely tuned radio signals automatically indicate artificial origin. The universe has proven capable of producing technological-looking signatures through purely natural processes. This realization has led to more sophisticated criteria for evaluating potential alien signals. Modern SETI programs now require multiple independent confirmations, complex signal patterns that would be difficult to produce naturally, and evidence of information content beyond what natural masers could create. The bar for claiming extraterrestrial contact has been raised significantly. But the WOW signal investigation also demonstrates the power of patient, methodical science. The recovery of supposedly lost data, the development of specialized analysis software, and the systematic elimination of alternative explanations show how scientific persistence can unlock cosmic mysteries decades after their initial discovery. The story also highlights how much we still don't understand about our own galaxy. The discovery that hydrogen clouds can produce such powerful radio emissions was unexpected and demonstrates that even familiar cosmic objects can surprise us. Future radio surveys are likely to discover similar events that will help refine our understanding of interstellar maser physics. Modern radio telescope technology gives astronomers unprecedented ability to study phenomena like the WOW signal. Arrays like the Very Large Array, the Allen Telescope Array, and planned facilities like the Square Kilometre Array can detect much weaker signals across much wider frequency ranges than the Big Ear telescope ever could. These advanced instruments have already begun detecting brief radio bursts that might be related to the WOW signal. Fast radio bursts, hydrogen line transients, and other newly discovered phenomena are expanding our catalogue of mysterious cosmic radio emissions. Some of these might eventually explain the intensity problem that still puzzles WOW signal researchers. The search for extraterrestrial intelligence continues with renewed sophistication. Rather than simply listening for powerful radio signals, modern SETI programs analyze signal patterns, look for artificial modulation, and search for information content that would distinguish alien technology from natural cosmic masers. The WOW signal's legacy extends beyond the search for aliens. It has taught astronomers about hydrogen maser physics, high-velocity cloud dynamics, and the importance of preserving scientific data. The techniques developed to analyze the signal have applications throughout radio astronomy. Perhaps most importantly, the WOW signal demonstrates that the universe remains full of mysteries waiting to be solved. Even after nearly 50 years of investigation, questions remain about what exactly happened on that August night in 1977. Future discoveries might finally provide complete answers, or they might reveal that the cosmos still holds secrets we haven't imagined. The signal reminds us that, whether we're alone in the universe or not, the cosmos itself is far stranger and more dynamic than we ever expected.